Okay guys, we're continuing with this Kirchoff's or Kirchoff's complicated circ problem. We went through and applied the junction rule and came up with this equation here. And now we're applying the loop rule and looking at the left loop. The left loop is this one here, obviously on the left square there. And what we need to know around the left loop is the change in voltage goes to 0. So if I'm starting at F, going to A, B, back to E, and back to F, I want to find out the voltage. So I'm going 0 here at F. I go across the voltage source. I'm in the direction of it, so I add 50. Now, as I go across this 10 ohm resistor with current I1, which I already designated, I'm going to lose voltage because I'm going in the direction of the current, sort of downstream if you want to think of it that way. And the voltage drop we know is equal to I times R. So that's going to be minus I1 times 10. Alright, I go across there. And that gets me to B. Now from B to E, what I'm seeing happen is I go in the same direction as current. So it's a minus. I'm losing I3 times its ohm. Resistor there is 10. And then from E to F, everything goes back to 0. So if I clean this up, my equation would basically be 10I1 plus 10I3 equals 50. And I'll call that equation 1. Now I could clean it up, divide by 10, and what I get is I1 plus I3 equals 5. So that's even better because it's cleaned up a little bit. Alright, let's go around and do another one. Let's do the right loop here. For right loop, I'm going to go from, I'm going to try to go in the same direction as current, so I'm going to go from B to E to D to C back to B. Alright, and real quickly, from B to E, again, I am losing voltage. There's a voltage drop because I'm going in the direction of current, so that's going to be a minus I3 times 10. From E to D, I'm going to add 60 volts because I'm going in the direction from negative to positive of the battery. From D to C, I'm going to lose voltage again, and that's I2 because I'm in the I2 branch now across here, times 10. And then from C back to B, I'm again going to lose voltage. That's minus I2 times another 10, and that has to equal 0. Now way back I could have combined these up just to make that a 20, but we'll leave them separate for now. So what does that come out to be? That comes out to be, let's see, add these two together, is 20I2 plus 10I3 equals 60. I get rid of a 10. I'll get 2I2 plus I3 equals 6, and that gives me a second equation. Alright, now I have a few moments here, so let's run through. I will do the outer loop. That's going all the way around the outside. We'll start with F. We're going to A to B to C to D to E back to F. And I'll try to do this one real quickly. That's going to be a 50 minus I1 10 minus plus I2 times 10. Now why is it plus all of a sudden when I get here? Well, I'm going upstream. When I go downstream, it's minus, like in this first one. I go upstream, it's there. Since there's two of them, I'm going to actually have a 20 here because there's a 10 and a 10. Now I'm going through the voltage source the opposite, so that's a minus 60, and that brings me all the way back to F, so that has to equal 0. So real quickly, that's going to equal a 60 at 10. Let's see, minus 10 equals 10I1 minus 20I2, if I did that right. Divided 10 out, that gives me I1 minus 2I2 equals minus 1. Alright, that gives me my third equation. So to solve these real quickly, we'd have these three equations in terms of I1, I2, and I3, and we have this guy here. So using these three equations, we have three unknowns. We could solve it. The fourth one helps us. We just do some substitution. And it's an ugly problem. That's how you do it. Hope it works out for you.